Okay, in this video, I'm going to discuss intermolecular forces. So the last video discussed bond and molecule polarity. So if you haven't watched that and you're not sure of how that works, you may need to go back to that because molecule polarity determines the type of intermolecular forces between molecules. So intermolecular forces are just the forces that hold molecules together. So they actually determine a ton of properties of molecules. Like, for example, they determine their boiling point. If the molecules are held together really tightly, then they're going to boil at a much higher temperature, okay? Now, the intermolecular forces that exist in a molecule are determined by molecule polarity and secondarily, the atoms in the molecule. Okay. So let's look at the three major types of intermolecular forces between covalent molecules and how we figure out which one we have. All right, so there's three types of forces: dispersion, dipole-dipole, and hydrogen bonding. Okay, and these are in order from weakest all the way to the strongest. Now, to figure out which intermolecular force you have to know the molecule's polarity. If I have a non-polar molecule, it always has dispersion forces. So this is the molecule overall, not the bonds. Then I have dispersion forces. If I have a polar molecule, there are then two choices. Either I have dipole-dipole forces, or I have hydrogen bonding. Hydrogen bonding is kind of like a special, extra strong type of dipole-dipole force that occurs when I have hydrogen bonded to nitrogen, oxygen, or fluorine. So I'm going to show you just a couple of examples to help you understand what types of force we have present. Okay, so first I need to know if the molecule is polar or nonpolar, and then I can figure out the IMF. So I'm going to draw you a couple of examples. Let's see. All right, now, one thing that I think is important to note is that all of these have polar bonds. And they have polar bonds because the bonds are between two different atoms, right? And we're assuming they have different electronegativity values. But we have to figure out if the molecule is polar or nonpolar. So the bonds in all of these are polar. The bonds are polar. The bonds are polar. Okay? Now, here, I have to look at the molecule and figure out, are the dipole moments going to cancel out? So another way to say that is this molecule symmetrical or asymmetrical? And your best clue is, are there lone pairs in the central atom? Are there lone pairs in the central atom here? They're not. So that means that this is a symmetrical molecule and the dipole moments will cancel out. So this molecule is nonpolar because the dipole moments cancel out. Now, in both of these cases, we have these lone pairs in the central atom, which is our clue that these molecules are asymmetrical. So that means that the dipole moments will not cancel out, and both of these molecules will be polar. Okay, so looking back, we said if it was a nonpolar molecule, the only option is dispersion forces. So since this is a nonpolar molecule, the intermolecular forces here have to be dispersion. There's just no other choice. Now here, since these are polar, we have two choices. They can either have dipole-dipole forces or they can have hydrogen bonding. And hydrogen bonding only exists when hydrogen's bonded to nitrogen, oxygen, or fluorine. Okay, so these are both polar. Let's look at each one and ask, do I have hydrogen bonded to nitrogen, oxygen, or fluorine? Well, I have hydrogen here, and it's bonded to nitrogen. So here, the strongest intermolecular forces are hydrogen bonding. Now here, it's a polar molecule, but I don't have any hydrogen at all, much less bonded to nitrogen, oxygen, or fluorine. So here the intermolecular forces are dipole, dipole. So sometimes you might just be asked what are the strongest intermolecular forces in this molecule, and you might think you can just jump straight to the answer, but you really do need to draw out the molecule, ask yourself about the bonds, then the molecule, and then the intermolecular forces follow a lot more easily. So I'm going to make one more video that kind of goes through a flow chart to summarize all of this.